Good day students. In this video we are going to discuss problem number 20 on MV Hinship. This topic is on free surface correction. Problem number 20 states that MV Hinship is floating at a mean draft of 7.5 meters. Her kg is 7.726 and these following tanks are slack. We have to find her GM fluid part A, and in part B we have to calculate her free surface correction if the displacement of the ship is 10,280 tons with the same slack tanks as above. So starting with part A, we have a draft of 7.50 meters. At 7.50 meters we find her displacement to be equal to somewhere between 15,226 and 15,693. When we interpolate for 7.50 meters between these two displacements, we get the displacement in salt water to be 15459.5 metric tons. For the same draft, we also have to find her km. At 7.5 meters, her km will be between 8.238 and 8.238. It's the same. So km is 8.238 meters. We know the formula for free surface moment to be moment of inertia multiplied by the density of the liquid in the tank. So number 3, port and starboard. We have to find the details of number 3, port and starboard, the moment of inertia, and since it is mentioned that it has got water ballast, we assume that water ballast to be salt water. So we go for number 3, port and starboard, moments of inertia. This is for cargo holds, storerooms, deck cargo stores, crew effects, deck cold spaces, domestic chambers, fuel oil tanks, diesel oil tanks, other oil tanks in the engine room, and we come to fresh and feed water tanks and ballast water tanks on this page number 15. Which tank do we have to find? Free surface moments, number 3, port and starboard. Number 3, port and starboard free surface moment for the port is 227 and for the starboard is also 227. So add the two and we get 454 m4. The unit for moment of inertia is m to the power 4. 454 into the density of the liquid in the tank gives us the free surface moment to be 465.35 ton meters. Number 3, center, also containing salt water. Number 3, center, also containing salt water. Her free surface moment is 1181 m4. So 1181 into 1.025 gives you her free surface moment to be 1210.53. Number 5, port DO tank. We go for DO. Number 5, port DO tank. Her moment of her free surface moment is 172. Into density of the liquid in the tank for diesel oil is 0.88. The product of these two will give you a free surface moment to be 151.36 ton meters. Number 5, starboard HFO. Number 5, starboard HFO. The moment for number 5 starboard HFO is 95. So we have 95 and the relative density of the liquid in the tank is 0.95. The product of these two gives us free surface moment to be 90.25 ton meters. Twin deck freshwater tank. We go for freshwater. Twin deck freshwater tank. Her free surface moment is 37. Twin deck freshwater tank starboard. Starboard, correct. Okay. So twin deck freshwater tank starboard. The moment, the free surface moment is 42. And the relative density of the liquid in the tank is 1. So the free surface moment is the product of these two giving us 42. Add up all the free surface moments, we get 1959.49 ton meters. Free surface correction formula, as we know, is sum of all free surface moments divided by the final displacement, which gives us 1959.49 divided by 15459.5 metric tons, and that works out to 0.127 meters. The part B of the question says what would be the free surface correction if the displacement was 10,280 with the same tank slack. Km okay, we revert back to part A. Km is 8.238, kg is 7.726, kg is 7.726 meters, that is given in the problem. GM solid therefore works out to the difference between km and kg at 0.512 meters. Free surface correction we have calculated above to be 0.127 meters, that is always negative. Therefore GM fluid works out to 0.385 meters. Now what happens when the displacement is reduced and the free surface moment stays the same for part B? So 1959.49, the free surface moment is the same, but the displacement has now been reduced to 10,280. Dividing free surface moment by displacement, we get free surface correction to be 0.191 meters. So as we see, when the displacement reduces, the free surface correction increases, provided that free surface moment stays constant. Now here I would like to go back to the tables to explain something about free surface moments. If you see over here, the free surface moments is given basis relative density of the liquid in the tank to be 1, which in effect gives you the moment of inertia. Moment of inertia into 1 will give you the free surface moments of the liquid of the tank, assuming that the liquid in the tank is fresh water. So whatever your answer here has to be multiplied by the actual relative density of the liquid in the tank, which is 1.025 for ballast water, and you have various relative densities for lube oil and cylinder oil and diesel oil and heavy fuel oil. So with that, we end this lecture on problem number 20. Thank you very much, students. Have a safe day. Have a great day. Goodbye. If you like this video, please give me a thumbs up, share and subscribe to my channel. Bye bye.